All right, class. Now we're going to go ahead and cover scientific notation. Scientific notation is a shorthand form for writing either really large whole numbers or really small decimal numbers. Now, in this case, we're going to use this format right here. You're going to have the number, the base 10, and if it's a whole number, your exponent will be positive. If it's a decimal number, the exponent will be negative. So once again, remember that if it's a whole number, you're going to go ahead and use a positive exponent for your base 10, and if it's a decimal number, a negative exponent. So let's do a couple of examples. They start you off in number 3A with the number 125. Now when it's a whole number, what you're going to do is you're going to go ahead and put the decimal point, if it doesn't have already one, second to the last place. So here we're going to put it right in between the 1 and the 2. So this will now be 1.25 times 10. And since you move 2 places, and this is a whole number, this will be a positive 2. Now keep this in mind. Think about it. 10 square. 10 square is 10 times 10, which is 100. If you multiply 100 times 1.25, it'll get you back that 125. So essentially, scientific notation is just a shorthand form for writing either very large numbers, whole numbers, or very small numbers. For the second example they gave you was 3,442. So once again, since it's a whole number, you're going to go ahead and put the decimal point second to the last place. So this will be 3.442 times 10. And once again, since it's a whole number, it'll be positive 3 since you move 3 places. So that'll be the scientific notation for that. Now for decimal numbers, it's a little bit different. It's not going to be second to the last place. What you're going to do is you're going to put the decimal point as soon as you hit a value that is greater than 0. In other words, 1 or greater. So for example, here we cannot put the decimal here. We haven't crossed over. So we're going to have to put it right there, right after the 2. So this will be 2.2 times 10. But keep in mind, this was a decimal, so the exponent now will be negative 2, since we moved 2 places right there. So it's 2.2 times 10 raised to the negative second power. Now our next example here, it's a little bit longer here. So in this case, we're going to move the decimal point and we're going to put it right after that 4. Once again, it's not second to the last like we did with the whole numbers. This one is as soon as you hit a value that is 1 or greater. So we're going to move 1, 2, 3, 4, 5, 6 places. So once again, 1, 2, 3, 4, 5, 6. So this will be 4.53 times 10 raised to the negative 6 power. So that would be your answer right there. All right. Now, part B, in this case, and let me write it down here. They're asking you to write it into standard form. Standard form is just a fancier way of saying you're going to go from scientific to a whole number form. In other words, you're going to go in reverse. So for letter B, they're giving you 2.04 times 10 raised to the third. So in this case, since it's a positive, that means that the decimal is going to move that many places to the right. So when we do this, this will be 2.04, and we're going to move it once, twice, 3 times. Since there's no value here, we're going to put a 0. So your answer for this one will be 2040. And that's your answer for that. So if you take a look at the next one that they're giving you, the next one that they're giving you is 1.9902 times 10 raised to the 7th. Same idea. We're going to move 7 places to the right since this is positive. Remember, when it's positive, it has to be a whole number. So we're going to move it once, twice, 3 times, 4 times, 5, 6, 7. Since we don't have values there, we're going to replace them with zeros. So this thing will be 19,902,000. And that would be your answer right there. All right. Same thing goes with decimals. In this particular case, they only gave you a negative exponent one right here. So whenever you have a negative exponent like this one, that means that this thing is going to be a decimal number. So instead of going to the right, that means that you're going to go to the left. So in this particular example, we have 9.311. So we're going to move 4 places to the left. So it'll be 1, 2, 3, 4. Since we don't have values there, we're going to put zeros there. So once again, it's going to be 0.000931. Now traditionally, you're going to have to put a 0 in front of the decimal point. That does not take a place right there. That's just a formality right there. And that would be the answer for it. So this concludes part 3.